The National Electrical Code, or NEC, does not provide a single, strict definition of low voltage as simply anything less than 600 volts. While 600 volts is a common threshold used in the NEC for differentiating between voltage classes, the code uses different voltage classifications depending on the specific application and context. To understand voltage classifications according to the NEC, it's essential to consider how the code addresses different voltage levels and their associated safety requirements. The NEC recognizes several voltage ranges, each with its own set of rules and regulations. Firstly, extra low voltage typically refers to circuits operating at very low voltages, often below 50 volts alternating current or 75 volts direct current. These circuits are used in applications where safety is paramount, such as control circuits, signal circuits, and some electronic devices. Secondly, low voltage is a broader category that generally includes voltages up to 600 volts. However, within this range, the NEC distinguishes between different levels of low voltage based on the specific application. For example, 120 volt and 240 volt systems are commonly used in residential and light commercial settings, while 480 volt systems are frequently found in industrial applications. Thirdly, medium voltage typically encompasses voltages above 600 volts but below 69 kilovolts. Medium voltage systems are used for power distribution in industrial plants, large commercial buildings, and utility substations. Fourthly, high voltage refers to voltages above 69 kilovolts. High voltage systems are primarily used for long-distance power transmission and distribution. Within the low voltage range, the NEC provides specific guidelines for wiring methods, overcurrent protection, grounding, and other safety measures. These requirements vary depending on the voltage level and the intended use of the circuit. For instance, the NEC specifies different wiring methods for 120 volt circuits compared to 480 volt circuits, reflecting the different levels of electrical hazard associated with each voltage. The NEC also addresses the concept of voltage drop, which is the decrease in voltage that occurs along a conductor due to its resistance. Voltage drop can affect the performance of electrical equipment and can also create safety hazards. The NEC provides guidelines for minimizing voltage drop by specifying appropriate conductor sizes and circuit lengths. Overcurrent protection is another critical aspect of electrical safety that is addressed in the NEC. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the appropriate size and type of overcurrent protection device for different types of circuits and equipment. Grounding is also essential for electrical safety. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to trip overcurrent protection devices and prevent electrical shock. The NEC specifies the requirements for grounding electrical systems and equipment, including the size and type of grounding conductors. In addition to these general requirements, the NEC also includes specific rules for certain types of equipment and applications. For example, the NEC has specific requirements for wiring swimming pools, spas, and hot tubs, as well as for electrical equipment used in hazardous locations. To determine the appropriate voltage classification for a particular application, it is important to consult the NEC and any applicable local codes or regulations. The NEC provides detailed information on voltage classifications, wiring methods, overcurrent protection, grounding, and other safety measures. It is also important to consider the specific requirements of the equipment being used, as well as the potential hazards associated with the application. It is also important to note that the NEC is not a design manual. It provides minimum safety requirements, but it is the responsibility of the designer or installer to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. In summary, while 600 volts is often considered a threshold for low voltage, the NEC uses a more nuanced approach to voltage classification. The NEC recognizes several voltage ranges, each with its own set of rules and regulations. It is important to consult the NEC and any applicable local codes or regulations to determine the appropriate voltage classification for a particular application. Understanding these classifications and adhering to the NEC guidelines are crucial for ensuring electrical safety. Furthermore, it is worth noting that the definition of low voltage can vary in other contexts outside of the NEC. For example, in some electronic applications, low voltage may refer to voltages below 24 volts or even lower. Therefore, it is important to be aware of the specific context in which the term low voltage is being used. The NEC also addresses specific requirements related to Class 1, Class 2, and Class 3 circuits, which are categorized based on their voltage and power limitations. These classifications are particularly relevant for control circuits, signal circuits, and other low-energy circuits. Class 1 circuits operate at higher voltages and power levels than Class 2 and Class 3 circuits and are subject to more stringent requirements. Class 2 and Class 3 circuits are designed to be inherently safe, meaning that they are unlikely to cause electric shock or fire, even under fault conditions. The NEC also provides guidelines for arc flash hazard assessments, which are used to determine the potential hazards associated with electrical equipment. Arc flash is a dangerous phenomenon that can occur when a short circuit or other fault causes a sudden release of electrical energy. Arc flash can cause serious burns, injuries, and even death. The NEC requires employers to conduct arc flash hazard assessments and to provide employees with appropriate personal protective equipment, or PPE, to protect them from arc flash hazards. The NEC also includes requirements for lockout/tagout procedures, which are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout/tagout procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect to prevent it from being turned on accidentally. The NEC also addresses the use of surge protection devices, or SPDs, to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, switching operations, or other disturbances on the power system. SPD are designed to divert surge current away from sensitive electronic equipment, preventing damage. The NEC also provides guidelines for the installation of renewable energy systems, such as solar photovoltaic, or PV, systems and wind turbines. Renewable energy systems are becoming increasingly popular as a way to reduce reliance on fossil fuels and to generate clean energy. The NEC includes specific requirements for the wiring, grounding, and overcurrent protection of renewable energy systems. In addition to these specific requirements, the NEC also includes general requirements for electrical installations, such as the use of approved materials and equipment, proper workmanship, and compliance with all applicable codes and standards. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is essential for anyone involved in the design, installation, or maintenance of electrical systems to be familiar with the NEC and to comply with its requirements. In the context of the NEC, understanding voltage classifications is critical for selecting appropriate wiring methods, overcurrent protection, grounding, and other safety measures. While 600 volts is often used as a general benchmark, the NEC considers various voltage levels within the low voltage range, each with its own specific requirements. Consulting the NEC and adhering to its guidelines are essential for ensuring electrical safety and compliance. Finally, it's worth emphasizing that the NEC is updated on a regular basis to reflect changes in technology and best practices. It is important to stay up to date with the latest edition of the NEC to ensure that electrical installations are safe and compliant. Additionally, local jurisdictions may have their own electrical codes and regulations that supplement or amend the NEC. It is important to be aware of and comply with all applicable codes and regulations. The NEC provides a framework for electrical safety, but this is not a substitute for sound engineering judgment and professional expertise. Qualified electrical professionals should be consulted for the design, installation, and maintenance of electrical systems. They can help ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. In conclusion, while the term low voltage is often used loosely to refer to voltages below 600 volts, the NEC employs a more detailed classification system that considers various voltage levels and their associated safety requirements. Understanding these classifications and adhering to the NEC guidelines are essential for ensuring electrical safety in all types of electrical installations.